All right, yeah, welcome back to the another segment of this course called data science. We have been looking at various subtopics under this subject for some times now. But today, we want to delve into what is called data visualization. Under EDA, we want to explore our data by visualizing it in different ways. And I just have two slides here to show, just to give us some kind of a background about our data visualization. So the concept of visualization is basically understanding your data set and the variables that comes along with it. Then would you be able to know what type of a chart you will be able to draw or display for a particular variable. For example, we have a variable. Just look at this sample of a variable here. We have gender, okay, we have age group, we have height, we have weight. So we are trying to look at different kind of variables here. Okay, looking at this now, you understand that we have a continuous variable here, height and weight. Okay, continuous variable height and weight. Right. We also have this this categorical variable here. All right. We have here both a gender and age group. So we should know what to use, what kind of a chart we can display with them based on our question we're trying to answer. So when we observe the data, for example, if you have one categorical for a variable, for example, like gender or age group, we can use a bar plot to display it. You have male, female, as a gender, male, female. Or you want to draw, you can also use a age group here, child, adult, elderly. It's male, female, that's mean two categorical. It means that in the adult we have adult, child, and elderly. We have male and female among them. All right. So we have gender, we have age group. So gender could, a child could be male or female. All right. An adult could be male or female. An elder could be male or female. All right. So this is called two categorical combined together. Now you have one categorical, another categorical, meaning two categorical combined together. So we also have a bar plot. This is called group bar plot. This is called group bar plot. So take note, because when you are drawing, you should be able to know what you are drawing. What type of data are you using to draw them, and for what purpose? All right. So when you have one numeric, for example, this is a numeric. For example, this one or this one, any one of the two, can use box plot. Box plot to display that, and sometimes you can use a histogram. Yes, histogram. Now, here we also have one numeric and one categorical. You can use a box plot also to do that. All right, as is one of this and one of this, or one of this or this and this. Okay, or you can use what they call box plot to display that. Or maybe you have two numeric, height and weight. You can use scatter plots. You can see weight here, height here. There are two continuous variables, all right, which possibly depend on each other. All right. So as the height increases, the weight increases at the same time. All right. So you understand this simple concept before we go into the drawing. So when you look at the table here, you say when we have one categorical data, we use bar plot or pie chart. When you have two or more categorical variables, you can use group bar plots or stack bar plots, which we saw just now. If you have one numerical, you can use box plot or histogram. Right? If you have one numerical and one categorical, we can use box plot. Right? We saw the example just now. One numerical and two or more categorical, can also use box plot. Right? If you have two numerical, can you scatter plots? Two numerical and one categorical scatter plots. That's when you group them by your categorical in different colors. So this is very useful for these two slides will be very useful for us as we journey in our visualization concept. So we'll be able to know what to use to display what. That is important. So let's go to the practical session now. All right, let's get practical as we look at our distance. So let's go to the R now. We want to use. We are trying to display our visualization using ggplot. All right, I know you are not new to ggplot, but if you are new, you're welcome. ggplot means grammar of graphics plots. Grammar of graphics plots. As in ggplot, grammar of graphics plots. So in concept, ggplot follows a pipeline of plot equals to data plus aesthetics plus geometry. So that is what it follows in concept. The plot means the final graphics, right? The data there means tabular data in table or in data frame, right? And the aesthetics there describe the visual characteristics that represent data in form of position, size, color, shape, transparency, filling, and scales. Okay, and the geometry there represents it actually defines the graphical representation in terms of histogram, such as box plot, scatter plot, which also define the type of geometric object that represent data, which means points, lines, polygons. That is what it represents both. Okay, so this is very important for us as we begin to understand. And even the grammar contains more definitions for graphics elements. The grammar in this particular ggplot. Okay, we have geoms, we have IS, we have scales. IS means aesthetics. Okay, short form, because when you are writing it, you don't write aesthetics in full. You write IS, which means AES. Okay, same thing with geometric. You have geoms, we have scales, we have stats, we have facets, we have theme. All those ones, they are grammar of that they contain in the definition of a graphic elements. So the geoms describe that type of geometric object that represent data, which I just explained now: points, lines, and polygons. The IS, which is aesthetic, describe the visual characteristics that represent position, size, color, shape, transparency, filling, and the rest of them. The scales are also described. The scale is for each aesthetic actually. Maybe log scales, color scales, size scale, shape scales. We have different kind of scales which we will see later. We have stats, statistics, which describe statistical transformation that typically summarize data. So, for example, counts, means, medians, regression lines, and so on. It can be embedded. It can be embedded inside the ggplots as we draw. Okay, we also have facets, which describe how data is split into subsets and displayed as multiple separate small graphics or small graphs. So we also have theme. Okay, theme controls the appearance of non-data elements. So this is a structure or what we have as a component of ggplot. To use ggplot library, one must install and load a ggplot like every other library. So which we have done that here. Actually, if you have installed library called Tidyverse, you may not need to install ggplot, but we just need to understand that we need to want to make sure that you know what you are doing, because you have to know that we are using ggplot. That's why we have to install it afresh. So we can run this line of code. Okay, can load it on the memory. When we click on it, it will load it. Then we can use it. We can use them. This Tidyverse is for data manipulation. All right, and this one is if our data set. This particular one, Pamen Penguin, is for data set. All right, this one is for visualization, or which I call control appearance of the non-data element, control the appearance of your for themes, and we also have a for plotting. Okay, so in the you can just say okay, plotting. appearance. You can see the data set. You can see data manipulation. Okay, that should be fine, right? At least to describe each of the lines. So now, if you run this line now, if you run everything now, like I just click now, you understand that the data set comes from this particular penguins. All right. So the data set name is called penguins. So we are going to look at these penguins and what it's all about. So let's first look at penguins. Let's glimpse penguin. Okay, let's glimpse it. Okay, let's see what is inside the penguins. Okay, you can see these are penguins. It has 344 8 columns. It has a column called species. Okay, it has a column called Iceland. These are factor variable. They are factors, which means they are categorical variables. Okay, we also have a B length, B depth, flipper length. Okay, you have a body mass, you have sex, you have year. All right, so these are the columns that we have there. And the penguin is one of the powerful data sets in R that I can use for data visualization, because it contains many features that you can actually use. Okay, it has almost every feature that you need, right? It has this, apart from the fact that it has let's summarize the data. Let's summarize and see what I'm talking about. In summarize, you have species column. You have 1, 2, 3. You have Adelie. You have Chinstrap. You have Gentoo. Right. In Iceland, we have Bisco. We have Dream. We have Togasin. All right. So these are the in this Iceland we have this species. Okay. For every island, in this island now we have the species here. All right. So you can have many species in one island. Okay. So that is just the secret. So we have a gender, which is sex here. We have a NA. You can see that you can see NA here, 11, NA2, NA2 here. So because the NA you have here, there are not many, 2 here, 2 here also. You can filter and remove not early elements, not to waste our time. So you can do that yourself. And if you want to remove, omit, you want to change it, you can use our previous method we have been taught to change it. So let's look at look at penguin first. Penguin 34, okay, and it's columns, okay. So if we remove now, we say penguin any that omits, let's omit and see what is there. So we have omitted this. Let's see how many that remains. 33 by 8. So you have not lost so much, okay. It's still okay. You have not lost so much, so we can do with this we have now. So all right, so let's describe this penguin. Let's look at what is penguin. All right, let's describe it. Okay, let's just type this penguin. All right, so all right, so we have site measurement of adult foraging penguins near Palmer Station, Antarctica. All right, so this includes measurement of penguin species island in Palmer archipelago, size, flipper length, body mass, B dimension, and sex. This is a subset of penguin raw data. So the data set is called penguins. A table with 344 rows and its variables. So species, a factor denoting penguin species. We have Adelie, we have Chinstrap, we have Gentoo. So this one denoting the species. We have 3 species. All right, 3 species in this penguin. We have island, a factor denoting island in Palmer archipelago, Antarctica. Okay, you have Bisco, you have Dream, you have Toginsin. So these are three islands that we have there, right? So in each island, we have different kind of species there. You can have all the three species in one island, if possible. You can have one or two species in any island. So we have B length, okay, in millimeter. We have it is a number denoting the B length in millimeters. We have B depth, a number denoting the B depth in millimeters. So inside the description, we have flipper length, integer denoting the flipper length. Okay, we have the body mass, the gram, and integer denoting the body mass in grams of the. We have denoting the sex, male or female, and the year we study here. The year we study the. So these are the. You can actually type penguin here. Let's just look at maybe you are new to what I'm saying. All right, this is penguin. Okay, look at it. Okay, this penguin. You can see. So we have male or female, so of them, and then we have a look at the flipper. Right. So we have to look at the flipper length and B length and all the rest. So these are what you are talking about. You can see penguin. This penguin. So in case you don't understand what penguin I'm talking about, so that is just so you can go back and work on this now. So like I showed you before in our slide, now we want to group our display into different forms. The first part is displaying one categorical variable with a bar plot. Okay, let's first see the let's see head penguin. Let's see the first term record of penguin. All right, we have a species. We have a species. Okay, we have island. We have B length. Okay, so this we have more four variables hidden here. All right, so if you run again, you should be able to see more. Okay, so we have the rest of variable hidden here. So this is just a sample of the what is inside of this data set, right? So you can see here very easily. All right, so we have one categorical variable with backplot first. We want to look at don't forget species is a categorical variable, all right? Island so categorical variable because they are factor variables. Okay, so we can plot using bar plot. So bar plot display the distribution of frequency of a categorical variable through vertical or horizontal bars. That's what bar plot what it does, what it plots. Okay, so we want to use a ggplot to do the plotting for us so that we'll be able to understand what we're talking about. All right, so excuse me. All right, so like I was saying, this one you can easily run ggplot. So this is a function called ggplot, right? The first thing we pass is pass our data set into it. Then secondly, we look at aesthetic, right? By explanation before, we have explained what it controls. Here we can have the dimension here, x-axis and y-axis pass to it. But because we are dealing with bar plots, all right, we only pass x-axis only, all right. The y-axis is automatic, is either frequency or count, so it's automatic. So now we say plus. You can continue and put plus here actually, but you can break it down to make the code easier to read. So geo m. So type of what type of what you want to plot bar. All right, you can still have some more thing inside here, but let's start gradually. If you plot this now around this line of code, it should show us this chart now. All right, so this is showing what species, each of them. Okay, you can see them here. You can also show the island also same. All right, maybe if we change this one to island instead of species. All right, so if you plot now, it will show you, to give you the same thing, but in different form. Okay, it's giving some error here. Let me attach penguin. Attach penguin. Okay, penguin is attached now, so then I can use it. So no, it's island, not islands. So that is where the error was. So let me go back now and tap island. So let's run again. All right. So we have Bisco, we have Dream, we have okay. So these are the islands. So we have more species. Okay. Okay. We have a lot in a Bisco than in a Dream, than in a Togesin. So the highest number of penguin we have is in Bisco, all right, and the lowest is in the lowest number is in Togasin, all right. So if you go back to species as well as we plot just now, you see that this species ideally is more than other ones, okay, followed by the Gen 2, and the Shin strap is the lowest species that we have. All right, so this is just how to plot. Okay, for example, now let's display what they call let me say table. You can have let's say we have an island, comma, we have species. Okay, so let's run this table. This one will show us the structure of our. You can see here. You can see what I'm trying to do here. So we have species, we have island here. So in this island, we have the number of each species we have is shown in this island here. In this first island, we have 44 Adelaide here. We have 0 Chintrap. We have 119 Gen 2 in this island. You go to Dream Island, we have 55 Adelaide here. We have 68 Chintrap, and we have 0 Gen 2. You go to Togasin Island, we have 47. All right, Adelaide, we have 0 Chintrap and 0 Gen 2. You can see. So this is what we have there for each island. All right. So you just try to show you the contingency table there, so that you can understand what I'm talking about. So now you can color this table, for example. All right. How do we do that? You look at what you have done here. Okay. How are the following two plots different? Right. All right. Which aesthetic color or fill is more useful for changing the color of bars? So we have a filling and we have a color. So if you run this now, you say, okay, this aesthetic equal to species again, geobar color equal to red. Right. So look at the second one. We have ggplot penguin, ISIS equal to S equal to V, which is correct, plus geobar fill equal to red. So which one is better? Now, if do we fill red or do we color red? And look at the first one. You see, color red. Now you only give it color outside here. Can see the outline of this bar is colored in red. Okay, but we say fill red, and you can see the fill red. So you can see the difference between the two, color red and fill red. All right, so this fill red is to differentiate each bar. All right. Okay, but color red is to fill entire bar. Okay, so take note of that. So that is just the first step. Second one is one numeric variable with a histogram or density. One numeric variable with histogram or density. So that is Second one we want to look at now, how do we do this? You must understand that histogram displays the distribution of continuous variable. All right, don't forget that by dividing the range of scores into a specified number of bins on the x-axis and displaying the frequency of score in each bin on the y-axis. All right, so that's what it does, histogram does. And the density also, density curve is a kernel density estimate, and it provides a smoother description of the distribution of scores. Kernel density estimation is a non-parametric in nature as a method for estimating the probability density function of a random variable. Kernel density plots can be an effective way to view the distribution of a continuous variable as well. So if we draw a histogram of this now, our data set is penguin. Okay, we call ggplot function as usual. Our aesthetic is what S is equal to bodygram. Okay, we want to draw histogram now. Histogram also is what we have only x-axis supply because the rest will be frequency or count. So here, if we want to specify the number of bins, we want 200. You can change the number of bins as you like. So we want to fill because this particular is not a species now. Don't forget, this species is a categorical. This is numerical. So take note of that. So let's see. But you can supply any one of the numerical here, continuous variable here to see. Look at it here. All right. This is our histogram. You can change the number of bins accordingly. Okay. If you say 20, for example, what do you have? I look like. If you say 100, what do you have? So you can change it as you want. So we also have density curve. Density curve, okay. The same thing you can use it. Just here we call it histogram here. You can see in geo underscore histogram here, geo that was density. It give us all our plot we are looking for. So if you run this line of code now for the same, you can see the density curve here. So this can also be fill. You can just color equal to, you can fill this one. You can fill with color as well. All right. So, but let's just move on. All right. Just type here as we do here. Okay. For here, to do here, fill equal to red. You can fill as well here. All right. You type fill. Fill equals to, let's say, equals to red. Let's see. Okay. You can see what I'm saying? So you can fill the density plot here, red. All right. So if you are plotting a numerical and a categorical variable with a bus plot now, what do you do? So we must first understand the concept of a bus plot, because the bus plots, otherwise sometimes we have there's not much difference between a bus plot and a whisker. Okay, they look alike. But it is described the distribution of continuous variable by plotting its 5-number summary. All right, 5-number summary. What do I mean by that? The minimum, the lower quartile, which is 25%, the median, 50%, we have 50 percentile, we have upper quartile, that's 75 percentile, and we have maximum. This 5-number summary is very important because these are the elements of box plot. So you can also display observations that may be outliers sometimes. That is to say values that are outside the range of IRQ, okay, where IRQ is the interquartile range defined as the upper quarter minus the lower quarter, okay. So let's look at the distribution of the body mass by species using geo box plot now. So if you pass our data set here as usual, we have our aesthetic here, our species here is here at x-axis, then our body mass is at a y-axis. So you can see now, this is our x-axis now, this is our y-axis. We want our species to be here, species 1, species 3. Then we have our body mass here to see distribution of this using box plot. So let's run this line and see what I'm talking about. See what I'm saying now? So we have Adelaide here, we have a Chinstrap, we have Gen 2. So look at this is the body mass. All right. you can change the title or this particular line to any name you want later, so that's not a problem, right? If you zoom this now, click on zoom, you can see here, you can see, okay, you can see there's an applier here in this second one. This dot here just means applier, all right? Okay, so we'll learn more about that as we proceed. So we can, while we plot, you can remove legend, okay? You can remove legend you want to see, but you want to plot and show color. So if we say, okay, it's S equal to species and Y equal to body mass, you can color by species now so that you can see the difference between each of them, all right? So you can color by species, and also we can remove, we can show legend equal to off or false. So let's run this and see what I'm talking about. So if we didn't supply this, for example now, okay, if we remove this, it will show the legend. Look at the legend I'm talking about here. You can see the legend here. You can see, but we don't need this because we already have a separate. We have a Gen2, we have Genstra. We already know which one they belong to, so we don't need this here. So that's why I off it here. All right, so to off, you can see, so it's not needed. You can remove it. So that's why we remove it. So you should know that you can remove a legend now. Take note of that. So alternatively, we can make density plot with a geo density as well. All right, by using the line with 0.75. If we supply this now for the density plot, we can run this line of code. All right, so we can see you can also remove the, okay, if you don't want to. All right, so we have a body mass here, we have density here, so we can see the line here. This line of Gen 2 here, this line of Adelaide here, and this line of Shin Trap. So you can see each of them in the density plot, right? Or you can also run it in this form. Maybe just change this one to 0.5, and we fill by species. You can fill by species, all right? So if you fill, you can see how it look like when you fill. You see, you fill by species. So you can also fill by Iceland, okay? But let's fill by species, and let's see, you can see them. So this is how you draw the diagram. So you can also have a line graph. A line graph of this one can be drawn also by choosing the bandwidth and line width. Alright, so if you say, okay, this is not from here, but we can convert this one to, let's say we have a penguin here, for example, as our lesson, and we have a body mass here, for example. We want to use this method to draw a line graph, okay? So here we can have our species here, color by species, okay? We can color by species here. All right, so we can draw this line width now, okay, and see what we have. Give geopolygon. All right, you want to give us line, that's what you give us. So if you run this line of code, you can have this line now. All right, so we also have two categorical variables. Okay, don't forget we have two categorical variables in this data set now called see two now, yes, two, island and species. So we can use a stack bar plot to visualize the relation between variables. All right, I use stack bar charts to do that, and that is very easy to do if we use a stack bar chart. For example, the one I removed just now is the one for what they call it now, diamond. I think we have done diamond. We have done diamond before. Yes. If you check, let me just let me come in. I want to run this and see the difference between this line and that line. Okay, so we have diamond. Let me see that. Let me see if diamond is still running. Okay, look at this. I look like, we have cut in diamond cut. If you remember, we have fair, we have good, very good, premium ID. We are not forgetting diamond data set. So we have this. You can look at how the price line, how it look like. Okay, so you can see difference between the chart now. So it's good for the price. It's not good for this. The line chart is not good for this type of. But it's good for this type. This one should show the price. Okay, it's like you are dealing with a forex exchange, for example. You can see the line of the this thing. So two categorical variables now. You can visualize stack plot. So when you say two categorical, you can use the stack bar plot to visualize the relationship between two graphical categorical variables. For example, the following two stack bar plot both display the relationship between island and species, or specifically visualizing the distribution of species within each island. All right. So if we run this, for example, if we run this stack bar plots, okay, visualize the relationship between the two categorical variables. So you can have, it's very simple to run. The same thing we have been doing since, just that you are going to bring your field in here. All right. So the x-axis is equal to island, field by species. That's all. Nothing special. So it's so simple to run. If you just run this line, you see that. Look at what you're doing. This is stack bar plot, right? So the first will show the frequency of each of the species, then going on each island. You can see this bisco, this is first island, second island, third island. So in each island, you can see their species. So we have more of species in the first island, more of a gentle in the first island. We have small Adelaide. So in the Dream Island, we have almost more of a chin strap there, and a little more of a Adelaide. But in Togerson, we only have Adelaide there. We don't have a chin strap. We don't have Gentoo. You can see. So this is called stack bar chart. Okay. It's very easy to draw. Can use for maybe gender and what they call it now. So and the one, like for example, the one I show now, you can use it for it. If you might in our chart now, if you remember, for example, which one I was showing just now, for this one, gender and age group, you can use it for it. Gender, age group. It's very easy. Like the one you do for two categorical here, you can see it. This is child, this adult. You can also use a stack bar chart for that as well. All right. So the second plot is relative frequency plot. Okay. The second plot for the this is a relative frequency plot. This is created by setting position to field, right? In the geometry. It's more useful actually for comparing species distributions across island, since it's not affected by the unequal numbers of penguins across the island. Right? Using this plot, we can see the Gentoo penguins all live in Bisco Island and make up roughly 75% of the penguins on that island. Chinstrap all live on Dream Island and make up to 50% of the penguin island on that island. And Adelaide live on 3 islands and make up all the penguin. So you can see the difference. So if we run the line, let's say we run by this species now. Let's run this line called this cluster now. You can see what I'm talking about. So all right. So the first plot shows the frequency of each species of penguin on each island. All right. So you can see the position of the field. All right. So you can see here. All right. Then if you run the cluster one in this format using Dodge here. So if you run this now, okay, I see some little difference. Okay, see what you can take it. So you can have side by side. That's what we saw here in this in here side by side. Okay, see a bar. That position, which is called Dodge. So we want to change that. We want to position the Dodge. So you can have side by side here. Okay, that's what we did just now. All right, so that will make our work much easier. All right, so we have to color species because we cannot differentiate here. We cannot hide the legend because we need to differentiate between which one is belong to which belong to each particular species. All right, so we also have mosaic bar plot. Okay, if you want to run the mosaic bar plot, you have to just load library called DG mosaic. All right, you have to load library before you can do that. So you can see call the same island, but in this case now we have to run mosaic instead of doing geo mosaic, aesthetic is equals to product island. You have to use product here, equal to island and phi species. So if you run this line of code now, you have a mosaic here. You can see. Don't mind the warning, okay? Just so you can see. This is mosaic. It's giving you roughly a rough sketch of everything, right, in a very easy way to understand. Okay, this is called mosaic plot. So if you are to run two monomerical variables with the scatter plot, for example, now, don't forget why we are discussing just now. I mentioned scatter plot, which is probably the most commonly used plot for visualizing the relationship between two numerical variables. Right, it's very common. So if you run this now, we have a flipper length. Don't forget, both must be continuous variable. Okay, left and right. I mean, x-axis and y-axis. All right. So let me just break down this one. Okay, let's leave it like this, as you can see. So let's just run this line of code first. You can see the plot here. So the relation between the body mass and flipper length, right? Body mass. So as the body mass, as the body mass is increasing, the flipper length also increasing. You can see that's a relationship between two of them. All right. So two numerical variables also and categorical variable can be also plotted together and be plotted together. So we have a body mass, flipper length. You can also include a categorical variable to it. These are two numerical variables now. We can include one categorical to differentiate, because that's the mean you can now color this can be colored. So to differentiate which one, because there are these are observations now. If you belong to the penguin, you can either color by species or by island. Okay. So now that's when you now have two numerical variables and a categorical variable. All right. For example, now we have here okay, don't worry about that. So for example, we can say, what is the relationship between flipper length and body mass of these penguins, taking into consideration the species. So we're looking at species as a consideration now. So let's plot it now. You can say take into consideration as island. Okay, that's how you can be plotted. So let's use, as usual, our data set plot here. Mapping equals to, can remove mapping, don't worry, see the same thing we have been doing since. So just say is equal to this, you can plot. Okay, so but now we say color equals to species. All right, so color equals to, but don't forget color is inside is here. Okay, so if you run this line of code now, you can see the difference. You can see here we have a mixture of Adelaide here, the Adelaide here, and the chin strap. Okay, here we have Gen 2 here. See, this is body mass, this is flipper length, this is two numerical variables which are continuous, and this is a one categorical variable here, showing here, giving us the difference between them. So we can see how they are related. Just you can see the relation between body mass and flipper length. All right. So we can specify what that we want to draw the line of best fit based on our linear model method with the LM. So you can draw the line of best fit here using the same method. So if you run this one now, all right, you can plus it won't give you many, but you can add this one to it. You can this smooth, okay, go to LM. All right, so if you run this line of code now, you can see that it can give you with line. Okay, for line is given for each. Okay, for this one we have line. If you want we have line, but it's including the standard error, which is not needed. So but you can just have one line, right? Since we want points to be colored based on species, but we don't want the lines to be separated out for them, we should specify color species equal to species for geo points only. So let's do that. Let's just supply our penguins mapping equals to AS, flipper length as usual, body mass, okay, geo point mapping equal to, so we are looking at IS equal to color equal to species now, then smooth equal to line. So we can separate this now. So we have one line here. So you can see this is what we are looking for. There's one line here. So you can see difference between this code and this code. So difference between the two. So we're not supplying our this thing here. Okay, because here we supply it in the points here. So that's why you can have one uniform line for all of them. That's what we are looking for. So you also understand the static mapping shape. So we have two numerical variables and two or more categorical now, two or more. So it means you can say what is the relationship between flipper length and the body mass of these penguins, taking into consideration the species and each island. Okay, we are taking into consideration both species and island now. For example, in the following scatter plot, the colors of points represent species and the shape of points represent island. So we want to look at it in form of two ways. So we can make one scatter plot, another one shape, so that you can able to see in a hierarchical order how you can visualize both on one chart. Okay, so we can say that this is a penguin as usual, flipper length, body mass, okay, then plus a geo point, highest color, species, and that's a shape equals to island. So this means that you have color equals to species, both shape, both species and island, they are both categorical variable, which you want to pass into this highest aesthetic now. So to make us give us the shape here and give us species here. So look at the plot here. Let's run this line and see what I'm talking about. You see now, so we are having different shapes. So species, look at the species, it gives us the color, but island gives us the shape. All right. So if I visualize this now, zoom this out, you can see what I'm talking about here. So look at it. So we know under each island how many species we have. Okay, by color and shapes, you can see for both body mass and the flipper length. So you see that. So you can now add title if you like. You can have a maybe let's say x axis, y axis. You can change it by using the labs. Okay, here because our title equals to body mass and flipper length. The y is equal to flipper length millimeter, y equal to this. So so just this is part of the title. So you can just you can say hard, you can just say hard. Why we run this one? All right. So we run together to show that the title. Okay, so it will be plus. Sorry, I'm supposed to plus this together with it. Okay. If you just run this line of code together. All right. So body mass is title. This is our S and Y axis. So you can this has changed now. Okay. You don't need this. Okay. That's already been supplied. All right. So another way which is particularly useful for categorical variables is to split your plot into facets. I talked about facet the other time. If you remember, subplot that each display of one subset of the data. So we can make it a facet wrap. So the same thing we have been doing since we're still doing using shape and the species, but now we call this line called facet based on island. All right. So we're going to group each island separately. This island, this dream, so and each of the species will be under them one by one. So that only one like this we can separate to three. Okay, we'll make our plot easy to read. All right. So if we run this line of code now, you can see that it will break it into three. You can see for each island now we have this. You can see. So this will have two, right? So you can see. So this is very good now. You can hide this if you don't want anymore. You can hide this now. At this point, you can hide our species because this one is going to give you different color. Okay, but we don't need to hide because we want to know the color. Which one is this? Which one is this? So is good. All right, so we also have what they call reporting statistic from a pair of correlation. Sometimes when you are displaying this kind of chart like this, you want to see the score being displayed. I mean, for example, now we run a correlations plot the other time now. For example, this one. Okay, you want to see how correlated they are. What is the value of their correlation? Okay, want to see uh, the correlation result of this particular two variables, how they are related. For example, the one we did just now. So we have to install package called smplot, smplot2, and this is how you so this just have to run this line of code, this two line of codes. Then when you are done, then you can call library. Let's say library. We call smplot, smplot2. All right, so smplot2, we run this line. All right, so now we can run this line now. What we want to use from smplot is this sm start correlation, so that you can show on top here our correlation here and our p-value, how significant this is. You want to see the result. So okay, so the same thing we have done here, we have been doing, we are still going to do again, so nothing different. Okay, but just this time around now, we just want to see how correlated this particular length and this one is. So you can change this one to something else. Maybe you have flipper length, you have flipper width. You can change them, body marks. You can change them and see results. If you leave this one like this, then we change it to flipper width to see how the touch changes. So it's very easy to see output. So you can try that. But let's run this and see what I'm talking about. All right, so now this is what I'm saying now. As you can see, this correlation. Our R is equal to 0.87. Okay, our p-value is significant. All right, so you can see the result display on it directly. So you can really save this and print it out like this as a normal chart in your manuscript or whatever. So you can see. So this is how you display everything together on one page. So we are able to see how to visualize our data using this dataset called Penguin. You can use another dataset you like. Just understand the concept of your data. Which one are categorical? Which one are continuous variables? Okay, which one are discrete variables? And which one do you want to use to present this to display this? That's why it shows that that slides just now, so that you can understand which one you use for this. Okay, so we will stop here for now under this, and we will continue in the next class where we bring more of this courses subject on our way. So thank you so much for listening today. I will see you in the next class.